The National Electrical Code, or NEC, Section 230.95 addresses ground fault protection of equipment for solidly grounded wire electrical services of more than 150 volts to ground, but not exceeding 1000 volts phase to phase for each service disconnecting means rated 1000 amps or more. This requirement aims to protect equipment by detecting and interrupting ground faults, which are unintentional electrical connections between a phase conductor and ground. However, there are exceptions to this rule. Exception number 1 to NEC 230.95 provides an exemption for solidly grounded generators. This means that if you have a generator that is rated 1000 amps or more and operates at a voltage greater than 150 volts to ground, it is not required to have ground fault protection of equipment. This exemption applies regardless of the load that the generator serves. The rationale behind this exception lies in the design and grounding of generators. Generators are typically solidly grounded, meaning that the neutral point of the generator winding is directly connected to ground. This solid grounding provides a low impedance path for ground fault currents to flow. In the event of a ground fault, the high current will quickly flow through this low impedance path, causing the generator's main breaker to trip and de-energize the circuit. This rapid tripping action helps to minimize the duration and magnitude of the ground fault, thereby reducing the risk of damage to equipment. It's important to understand the relationship between exception number 1 and fine print note number 3, or FPN number 3 to NEC section 230.95. FPN number 3 suggests that ground fault protection may be desirable for personnel safety. However, exception number 1 takes precedence over FPN number 3 in the case of solidly grounded generators. This means that even though ground fault protection could potentially enhance personnel safety, it is not mandated by the NEC for generators that meet the criteria outlined in exception number 1, that it is rated 1000 amps or more and operates at a voltage greater than 150 volts to ground. In practical terms, this exemption provides flexibility in the design and installation of generator systems. While ground fault protection can offer additional protection, it is not always necessary for solidly grounded generators due to their inherent ability to quickly clear ground faults through the solid grounding connection. When working with generator systems, it is crucial to carefully review the NEC requirements and any applicable local codes to ensure compliance. Understanding the specific exceptions and their underlying rationale is essential for making informed decisions about the design and protection of these systems. It is also imperative to consider the specific characteristics of the generator, including its grounding configuration, voltage rating, and ampacity, to determine the appropriate level of protection. While the NEC provides a baseline for electrical safety, it is always recommended to consult with qualified electrical engineers and other experts to assess the specific needs of each installation and to implement best practices for electrical safety. This may include additional protective measures beyond the minimum requirements of the NEC depending on the specific application and risk factors. In addition to the NEC requirements, it is also important to consider the recommendations and guidelines provided by generator manufacturers. Many manufacturers offer specific recommendations for grounding, protection, and maintenance of their equipment. Following these recommendations can help to ensure the safe and reliable operation of the generator system. Regular inspection and testing of the generator and its associated protective devices are also essential for maintaining electrical safety. This includes testing the operation of the main breaker, ground fault relays, and other protective devices to verify that they are functioning correctly. Furthermore, it is important to ensure that all personnel who work on or around generator systems are properly trained in electrical safety procedures. This training should include instruction on the hazards associated with electricity, the proper use of personal protective equipment, and the procedures for safely operating and maintaining generator systems. By following these guidelines and best practices, you can help to ensure the electrical safety of generator systems and protect personnel and equipment from the hazards of ground faults. Remember to always consult with qualified electrical professionals for specific guidance on the design, installation, and maintenance of generator systems. NEC 230.95 is very specific, and it applies only to solidly grounded wire electrical systems. A solidly grounded system is one in which the neutral conductor is intentionally connected to earth ground at the service entrance. This provides a low impedance path for fault current to flow back to the source, which helps to quickly clear ground faults. In contrast, an ungrounded system does not have a neutral conductor that is connected to ground. In an ungrounded system, a ground fault will not cause a large current to flow, but it will raise the voltage of the unfaulted phases with respect to ground. This can create a dangerous situation, as personnel who come into contact with the unfaulted phases may experience a shock. Higher resistance grounded systems use a resistor to limit the amount of current that can flow in the event of a ground fault. This type of system is often used in industrial applications where it is important to maintain power to critical equipment, even in the event of a ground fault. An impedance-grounded system uses an impedance such as a reactor to limit the amount of current that can flow in the event of a ground fault. This type of system is often used in applications where it is important to reduce the magnitude of ground fault currents to protect equipment. The exception to NEC 230.95 applies only to solidly grounded generators rated 1000 amps or more and operating at greater than 150 volts to ground. It does not apply to other types of generators or to generators that are not solidly grounded. It is important to note that even though ground fault protection is not required for solidly grounded generators under certain conditions, it may still be desirable to provide this protection for personnel safety or to protect sensitive equipment. The decision of whether or not to provide ground fault protection should be based on a careful assessment of the risks involved in the specific requirements of the application. Ground fault protection devices, or GFPDs, work by monitoring the current flowing in the phase conductors and the neutral conductor of an electrical system. In a balanced system, the current flowing in the neutral conductor should be equal to the sum of the currents flowing in the phase conductors. If a ground fault occurs, some of the current will flow to ground through an unintended path. This will cause an imbalance in the currents flowing in the phase conductors and the neutral conductor. The GFPD will detect this imbalance and trip the circuit breaker, interrupting the flow of current to the faulted circuit. There are two main types of GFPDs: ground fault circuit interrupters, or GFCIs, and ground fault relays, or GFRs. GFCIs are designed to protect personnel from electrical shock. They are typically used in residential and commercial applications where there is a risk of contact with water, such as bathrooms, kitchens, and outdoor areas. GFR are designed to protect equipment from damage due to ground faults. They are typically used in industrial and commercial applications where there are large electrical loads. The selection of the appropriate GFPD for a particular application depends on several factors, including the voltage and current rating of the electrical system, the type of load being served, and the level of protection required. It is important to consult with a qualified electrical engineer to determine the appropriate GFPD for your application. In addition to the NEC requirements for ground fault protection, there may also be local codes or regulations that apply to generator systems. It is important to check with your local electrical inspector to determine if there are any additional requirements that you must meet. Regular maintenance and testing of generator systems are essential for ensuring their safe and reliable operation. This includes inspecting the generator for any signs of damage, testing the operation of the main breaker and other protective devices, and performing regular maintenance on the engine and other mechanical components. It is also important to keep accurate records of all maintenance and testing activities. These records can be helpful in troubleshooting problems and demonstrating compliance with applicable codes and regulations. Working with electricity can be dangerous, so it is important to take precautions to protect yourself from electrical shock. Always wear appropriate personal protective equipment, such as rubber gloves and safety glasses, when working on electrical equipment. To energize the circuit before working on it whenever possible. If you must work on a live circuit, use extreme caution and follow all applicable safety procedures. If you are not qualified to work on electrical equipment, do not attempt to do so. Hire a qualified electrician to perform any electrical work that you are not comfortable doing yourself. By following these safety precautions, you can help to prevent electrical accidents and injuries. In conclusion, while exception number 1 to NEC 230.95 exempts certain solidly grounded generators from the requirement for ground fault protection, it is important to carefully consider all of the factors involved before making a decision about whether or not to provide this protection. Consider the specific requirements of the application, the recommendations of the generator manufacturer, and any applicable local codes or regulations. Remember that electrical safety is paramount, and it is always best to err on the side of caution. Consulting with qualified electrical professionals can ensure the safe and compliant design, installation, and maintenance of your generator system.